right? So think about the first article that we started out with. We had child education is a function, a constant plus family income plus a bunch of family controls. Maternal education, family structure, you name it. We tried to put in a lot of things in order to get an estimate of B1 that was, it wasn't directly causal because it wasn't an experiment. We weren't randomly assigning income to families. But if we think about confounding variables that might mess up B1 as a causal estimate of the effect of income on child outcomes, we had quite a few variables in there. So one of the very illuminating articles that Drew Bailey actually brought my attention to was that Gilman and Imbin's article that you read. This distinction, right, between forward causal inference versus backward, maybe it's reverse. Was it reverse? Causal explanation. And, I was a spectator to many rounds of confusion when economists and policy people would try to talk with developmental psychologists and education researchers. And it usually turned on this difference. And it was a revelation to me when I realized that. He calls it reverse, they call it reverse causal inference, right? So you could think about this equation in the two different ways here. Reverse causal explanation asks, why do kids end up with different levels of education? And that gets you right to Bronfenbrenner, child, family, neighborhood, policy, right? You all went over Bronfenbrenner in the foundations class for human development, right? It's a standard part of it. What are all the things that might bear on why kids end up with different levels of education? That's a worthy line of endeavor, but it's very different from the focus of the article, and the focus of experiments, which is trying to identify a causal effect of a variable, in this case, family income, on an outcome, education in this case. So if we think of forward causal inference and reverse causal explanation, who does forward causal inference? Experimenters, economists, policy analysts, for the most part. They want to know what the effect of a policy is on outcomes like child education. Who does reverse causal explanation? Non-experimental psychologists, Education researchers, most education researchers. Most qualitative researchers. Right? You go into the field and you really want to try to understand something. Everything that's feeding into why families or children are as they are. So it's different groups of people. The idea for the forward causal inference people is to manipulate some X to see its effect on Y. And we can do that experimentally. Or we can do it quasi-experimentally. And we'll talk at length over the course of the quarter about what quasi-experimentation is. So that's the goal of forward causal inference, to manipulate an X to see its effect on Y. And for reverse causal explanation, you want to explain Y as completely as possible. Hence the Bronfenbrenner diagram. For the reverse causal explanation people, R squared is important. It's kind of a measure of how you're doing. You know, if you're trying to explain things as completely as possible, the higher the R square indicates, the more complete your explanation is. For forward causal inference people, R squared doesn't matter. So if I'm trying to isolate the effect of family income on child education, you know, we talked before about how additional control variables sometimes helps reduce the standard error and make a more precise estimate. That's valuable. But the whole philosophy of reverse causal explanation approach is to try to include variables from all the possible layers of influence and try to come up with an idea of where the action is, right? Here, you don't care about where the action is. You're only interested in one variable, and you're either manipulating it directly or you're trying to come up with quasi-experimental data where some policy or some event manipulated it for you.
Greg?
Yes.
So I'm not quite understanding why R squared doesn't matter in a forward causal inference, because even if we know, for example, we're looking at the effect of family income on child's education, wouldn't we want to know how much of that variation can be explained by family income in a forward causal inference question?
Usually not. I mean, think about the policy question. I want to know whether a $4,000 a year child allowance that might in fact be part of the next package that the Democrats come up with. I want to know whether a $4,000 a year child allowance is going to have an impact on children's achievement and their eventual educational attainment. Okay, so I want to know the coefficient here. I don't want to know the R square, right? You know, in general, the higher the coefficient, the bigger the R square, but it, you know, that's a minor, you know, it's it's an artifact of the connection between a coefficient and R-square. It's not an important indicator of success for me. The indicator of success for me, if I'm forward causal inference, is thinking, I've really nailed down what the causal effect of, in this case, income on completed schooling is. That's the goal.
Following up on that with, for example, hierarchical regression, because sometimes like when variables are added in steps, like researchers will report the additional variance that it's explained. So it does seem to like they're putting an emphasis on it. So I was thinking the same as Tiffany that.
Yeah, that's a total reverse causal explanation approach. You never see that kind of hierarchical adding in variables in a forward causal inference approach.
Okay, interesting. Thank you.
Yeah. So it's not completely true, but it's not true in a way that's too, we'll get to it later, trust me. And then finally, other coefficients other than the key one, which is in this case on family income, are uninteresting. Who cares about them? They're a distraction. We want to know, how do we get that best unbiased estimate of the coefficient on family income? For reverse causal explanation, almost all coefficients are interesting. Right? You've got family variables, you've got neighborhood variables, you've got community variables, macro policy variables. You want to know where the action is. And that's indicated by often standardized coefficients. So those coefficients on all the variables you're interested in. You want to be able to compare across those coefficients. For forward causal inference, it doesn't make, they're not interesting at all because they detract from attention to the primary focus, which is to identify a causal effect, in this case of family income on completed schooling. So again, you get these conversations where I did a couple papers with Bob Siegler, who's a really big math guy, really nice guy, smart. And we were estimating these equations looking at the effect of, I think we were looking at the effect of fraction knowledge in fourth grade on algebra achievement 3 or 4 years later. His idea was that fraction knowledge was really the key to understanding algebra. And if kids were more advanced in terms of fraction knowledge, they'd be better able to understand algebra. So, we really tried to estimate that effect, but he kept saying, well, look at this coefficient on family income. Isn't that interesting? And we'd all say, no, it's not interesting. We're not interested in that at all. We're interested in identifying the effect of knowing fractions on later achievement. So it was a perfect illustration of the different kind of thinking in these two different approaches. So this approach strives for policy conclusions or policy implications. This, people strive for policy implications all the time. but I would argue this tells you very little about policy implications. Because policy is all about manipulating something to see if it's affecting something that you care about, and that is a causal question. If you end up estimating a Bronfenbrenner model and find a component of neighborhood is significantly correlated with some child outcome, maybe, well, it only tells you something about neighborhood policy and its effect if you have convinced yourself that you've identified a causal impact of that component of neighborhood on the child outcome. And that's not really the goal of what reverse causal explanation is. So people who adopt this approach, and I don't want to demean this approach, right? You really do need a lot of excellent reverse causal explanation work to generate hypotheses that you then try to subject to forward causal inference testing. So it's very valuable. But people usually do this, stop, and then try to talk about policy implications. It drives me crazy. And only if you have a convincing causal analysis can you talk about policy in a warranted kind of way. Again, we'll talk about this more and more over the course of the quarter.
So Greg, go ahead.
Yeah, go ahead.
No, Brian, you go ahead.
So is it fair to kind of, I'm trying to stay with your line of thinking with that. Is it fair that maybe on, I guess, RCE, I guess, is trying to, or reverse, trying to think about like where they're applicable, right? So one is trying to verify a model, I guess, maybe all the coefficients in a model, but it's not necessarily an answer. Is that what you're saying? Whereas forward causal inferencing is probably more of getting to kind of what an answer would be. I don't know if that makes sense what I'm asking there.
Yeah, well, it depends on what question you're asking, right?
Yeah.
And if the question is, what's the impact of neighborhood social cohesion on child well-being, child deviancy, let's say, that's a forward causal inference question, right? And you really want some kind of manipulation like movie to opportunity, that experiment, right? To answer that question. If you investigate neighborhood social cohesion as one of the many possible correlates of the child outcome, you might end up with it being one of the more potent in terms of explanatory power components of neighborhood. And that's a very interesting result. And it's very suggestive that you need to go to the next step and do the experiment or do the quasi-experimental manipulation. But it's not in and of itself telling you it's important because you haven't manipulated it in a way that is answering it in a definitive way.
Thank you.
Someone else was asking a question. Was it Tiffany?
Yeah, I had a question, but you kind of just answered it. So thank you.
Okay, well, that's good.
I had a question.
Sure.
Is there always a clear-cut line between forward causal inference and reverse causal questions? Yeah, go ahead.
Well, go ahead.
No, it's just that when I read certain papers or articles, it seems like they start off with a why question and then go into kind of like searching for which variables are more important. So it seemed to me that they start off with a reverse causal question and then kind of do their research with the forward causal inference, but maybe I was just wrong.
Well, if it's usually if it's just one analysis, they're really completely within the reverse causal explanation mode. They might identify several variables that have big coefficients and seem to be potent explanatory variables for the outcome of interest. And often then they take the step, well, they've got a big standardized coefficient. They account for relatively more of the variance of the dependent variable. Therefore, they have a bigger causal effect. And that's the step that I would argue you simply can't make from a reverse causal explanation analysis, right? You should just stop and be happy that you've done something very valuable, which is to identify where the action is. But if you really want to take the step into policy, you've got to come up with more convincing evidence than just, some standardized coefficient from a regression that includes a whole bunch of stuff.
Excuse me. So what I understand is that there are in reverse causal questions, we have something that we want to find the reasons for. So after that, we might find some candidates for causes, and then we might like do an experiment after that to find some like relations between those variables in the outcome, and by those weights, we can maybe like analyze if what could be the cause of that effect, something like that, right?
I could not have said it better myself. That's perfect. And
Thank you.
yeah, sure. So, just to give you an example, it's very important to know what the effect of family income is. I've spent a lot of my career trying to identify it, mostly with non-experimental methods. We're finally doing an experiment. But, if you think about going from a reverse causal explanation over to a forward causal inference on family income and don't have an experiment, the trick, and again, we'll talk about this in more detail, is to try to identify natural experiments, quasi-experiments, that are manipulating family income in a way that's beyond the control of the families that you're studying. Okay, so there's one article that's very famous that takes advantage of the fact that in North Carolina, in the Great Smoky Mountain area, there was a wonderful developmental study that began. It sampled, 1,000 12 and 13-year-olds across several different counties, followed them over time, got it just a ton. It's a very rich developmental study, and it happened that in those counties at that time, there were quite a number of Cherokee native people living there, and it turned out that a big casino came in. And the casino that came in when the kids were, 14 or so, the casino set up, they generate a lot of money, and they give a lot of the money to the tribes, and they disperse it to their members, right? And the amount was quite substantial. It was like $5,000 a year to every individual who was identifiably a member of the tribe, right? So embedded in this developmental study, you have kids whose both parents are members, are Cherokee, one parent is a Cherokee, or neither parent is a Cherokee, right? So out of nowhere, you get this change to your family income, totally beyond your control, that is just a function of the heritage of your parents. And they were able to see, well, controlling for where they were before the casino came in is the outcome that you see when the kids are 20, 21, 22 years old, depending on how many Cherokee parents they have, right? And you can, it turns out it makes a big difference. And it appears that $5,000 of income has a quite significant effect on completed schooling. Because kids who are observationally similar back at age 12, when the study started, end up with quite different education levels, simply depending on how many of their parents were Cherokee. So that's an example of a natural experiment that manipulates income in a way that's beyond the control of the families, right? So this is one of the points on the Heresy 101 sheet. It's often the case that people start out ECLSK. I get that. I've learned about the ECLSK in this class. I'm going to apply it to some problem I'm interested in, right? And for reverse causal explanation approaches, that's fine. If you really want a forward causal inference approach that's convincing, you usually can't start with the data set you're familiar with. You have to look out in the world for these events that happen that are producing variation in your independent variable of interest that you might be able to gather data for to address this causal question, in this case of the causal impact of family income on child education, right? So it's instead of starting with a data set and starting to milk the data set for interesting analyses, you start with the question, in this case, what's the causal effect of income on education? Try to identify out there in the world interesting policy changes or other kinds of occurrences like the casinos that are manipulating your independent variable of interest in a way that's beyond the control of the families that you're studying. So it's just a different approach to identifying how you'd go about doing an analysis. All right, we're in the final minutes of our class period. I'm energetic, but I'm always energetic when I'm teaching. We've got a little poll for you. One thing I'd hoped to get to, and I didn't. Let me share. Let me bring it up first. So this is something that was embedded in the syllabus. So can you see this calculating and communicating about regression coefficients?
Mm-hmm.
Okay, good. Take a look at this. This is all about the various ways in which you can express coefficients. You know, we've kind of done raw score coefficients up over here. We just took Y scaled however it was. And then when we had that treatment equation, the treatment variable was just a 1, 0. You know, it was scaled in raw units. So, you know, a change in the dependent variable associated with a 1 unit change in X. But that's just one way to do it. You can do an effect size, you can do standardized coefficients. Percent change, someone suggested that as a way of understanding the difference between 100 and 110. Elasticity, which is percentage change. Months of learning, we'll talk about that. And then these kind of benefit cost coefficients. So take a look at that. We'll talk about that first thing next week. Next week is Martin Luther King Day. It's coming to class is I'll have class at the regular time. I don't expect everyone will be able to come. That's fine. We'll record the class as usual. And then on the following Friday, we'll take our 1 hour perhaps and devote it to understanding, taking questions that people might have had about what went on in the lecture. Okay, so please take the poll that Paul is about to launch, and I'll hang around a little bit if people want to ask questions. Ooh, can I answer it too, Paul?
I think so.
Too easy, let's get moving. Okay, so please drop off if you want to drop off. If anyone has any questions, now might be a good time to talk about them.
Okay, so I'm hooked. So, but
Excellent. Well, I'm sorry. So I'm looking at the poll. Is everyone
sorry.
seeing this, Paul?
I think so.
All right. So 0 not getting it at all. That's great. Okay, so send this to me, okay, Paul?
Okay.
Okay, sorry, Brian.
No, I was looking at the poll too. So I didn't want to ask this in question. I mean, in class, but you say for reverse causal question, you say explanation instead. Is there a reason why? Does that make sense? What I'm asking?
Yeah, it's actually what Gelman and Imbens, it's their language. And I think it's good because, inference implies, statistical hypothesis testing, in this case about causal effects. But reverse causal inference is really about explanation, right? It's not about testing explicit hypotheses. It's really about seeing where the action is for the most part. So I think that language is good. I might say, FCI and RCE, I've never seen it used before. I put it up on the board because I was too lazy to write it out again. So, you shouldn't just talk about RCE and expect people to understand what you're talking about.
Thank you.
Can I also ask a question?
Sure, yeah.
So I think after your explanation, like some of the studies that I have considered like forward are probably more explanatory than I initially thought about them. So I wonder if that has to do with like the way that hypotheses are framed or research questions are framed, and then the actual analysis that is conducted. So
Yeah,
I gave an example of like hierarchical regression earlier, and I feel like that is used, at least I have seen it being used like in a forward causal kind of like model or like approach. So I do wonder, like, do researchers sometimes do that? Like put it in a way and then do it in an analysis in a different way?
So we'll talk about this later, but suppose I have family income as my primary independent variable of interest, and then child education as my primary outcome. And suppose I have a mediating model, right? I'm thinking, well, family income is going to lead to a cognitively stimulating home environment. Right, so I might start out with family income and then have a subsequent measure of home environment, and then an even more subsequent measure of education, right? It's kind of a classic mediating model. If I want to estimate this model, let's say I've got a income manipulation, casinos, actual random assignment. Paul and I are working on an experiment that actually randomly assigns income to low-income families with newborns. If I've got experimental manipulation of family income and want to know about this mediation, I can estimate an experimental impact on child education. And that's going to be kind of the bottom line overall impact. If I want to know how much of that goes through cognitively stimulating home environment, these are the kind of models that you estimate in SEM, but you never see an economist estimate a model like this because you can really nail down with the random assignment design, you can really nail down this path because you've got experimentally manipulated income affecting home environment. But you can't nail down that path because you haven't manipulated the home environment. You've only manipulated family income, right? So an economist would be content with estimating this impact and maybe doing a hierarchical regression where you have child education is the dependent variable. And then you've got family income, and then cognitive stimulation. So your first model might only have family income, but not cognitive stimulation. And the second model might have both of those, right? And then you can see, well, by how much does the coefficient on family income, its effect on education, fall when you add in cognitive stimulation, right? And that's a kind of an indication of potential mediation. But that's the only way that you're going to see a kind of a stepwise approach taken in a forward causal inference study. You see it all the time in the reverse causal explanation studies. People will, start out with the family level influences. They'll add in neighborhood. They'll add in, state policy variables. But that's for a different purpose. That's to try to look at how much additional explanation that you get when you throw in neighborhood and over and above family, when you throw in state over and above family and neighborhood. So it's done in both approaches, but for very different reasons.